Let us see how to write the Verilog code for D flip-flop using positive edge trigger. So every Verilog code starts with a keyword called as module. So module name. Here module name that I'm using is D flip-flop underscore positive edge trigger. So module name. Next comes port list. So in D flip-flop, if you observe, output is Q. Inputs are nothing but D followed by clock. And every line should end with a semicolon. Next, we need to write port declaration. So port declaration is nothing but among D, Q, and clock. What are the inputs and what are the outputs we need to declare here. So here output is nothing but Q and inputs are D and clock. Here I'm following a style called as behavioral modeling. So in behavioral modeling, there is a keyword called as always at the rate. As I'm going with positive edge trigger, so here we need to give as pos edge. So always at the rate of positive edge of the clock, the following statement should get executed. So case, so here there is no need for you to use any concatenation operator as there is only one input variable, that is D. So case D, so here two combinations will be there for a single variable which can be either 0 or 1. So one take binary 0. So when D is equal to 0, output which is nothing but Q will be equivalent to D, and for one tick B1, B stands for binary. For one tick B1, again output is nothing but D only. Why? Because in D flip-flop, if you observe the characteristic equation, Qn plus 1 will be equivalent to D. So whenever there is a case, it should end with end case, and whenever there is a module, there should be end module. And as this is behavioral style of modeling, output should be declared as register, and better try to assign some previous value for Q. So I'm giving value here as 1 tick B 0. So this is how we can write the Verilog code for D flip-flop using positive edge trigger. That is, when clock is going from 0 to 1, depending upon the inputs, output will get affected.